Welcome to the deep dive. So, you know those really impressive demos you see? LLMs just nailing single questions.
Uh-huh. The ones where everything's laid out perfectly.
Exactly. Well, today we're digging into some really interesting research that shows things get, well, a lot trickier when these AI models have to actually hold a conversation, back and forth.
Right. It's a different ball game entirely.
Prepare for a bit of a surprise, actually. This study found, on average, a 39% performance drop when LLMs have to deal with follow-up questions or, like, incomplete instructions.
Yeah, it's a big number. And it makes sense because we've been so focused on that single-turn performance. How well does it answer one question?
But that's not how we talk, is it?
Not at all. We almost never give all the information up front. We clarify, we add details as we go. And this research, it's from Philip Lobon and some colleagues at Microsoft Research and Salesforce Research.
Okay.
It really pulls back the curtain on how LLMs cope with that more, natural unfolding kind of chat.
And this idea of underspecification seems key here. What exactly is that?
It's basically when the first thing you say isn't the whole story. The AI needs more context, more details. Maybe it needs to ask questions.
Like if I just said, hey, AI, plan a trip for me.
Perfect example.
Yeah.
That's totally underspecified. Needs to know where, when, budget, who's going, all that stuff.
Right.
And to really sort of simulate this, the researchers came up with a pretty clever method. They didn't start with vague stuff. They took existing, perfectly clear instructions.
The kind used in normal benchmarks.
Exactly. Instructions where all the info is there. And they broke them down into little pieces. They called them shards.
Shards. Okay, interesting. So can you give an example? How does a full instruction become these shards?
Sure. They used this snowball fight scenario. A full instruction might be something like, Jay makes 20 snowballs an hour for a fight, but 2 melt every 15 minutes. How long until he has 60?
Okay, yeah. Everything's there. Math problem.
Right. Now, the sharded version would unfold turn by turn. Turn 1, the AI just gets, how long before Jay's ready for the snowball fight?
Incomplete.
Very. Then, the next turn might reveal, he's preparing for a snowball fight with his sister. Then maybe, he can make 20 snowballs every hour, and so on.
Ah, I see. So the full picture emerges gradually, like in a real conversation where you're feeding information bit by bit.
Precisely. It mimics that back-and-forth clarification process.
So it's like the AI is solving a puzzle, but only gets like one piece at a time. How did they actually run these tests? What was the setup?
They designed the simulation with 3 sort of parties involved. First, you have the assistant, that's the LLM being tested.
Got it.
Then there's a user. Now, this user is actually another LLM, and its job is to deliver those instruction shards one turn at a time, trying to make it sound natural.
Clever. Using an LLM to simulate the user.
Yeah. And finally, there's the system. This is the evaluator.
Hmm.
It watches the assistant's responses each turn and ultimately decides if the task was completed correctly.
And what kind of responses could the assistant give? It's not just about the final answer, right? Especially when it only has partial info.
No, definitely not. The system categorized the responses. Sometimes the assistant would ask for clarification, which is often the right move.
Makes sense.
Other times it might refuse, saying it doesn't have enough information yet. Or it might hedge, give a kind of tentative answer, or even just start a discussion without attempting the task.
Okay.
And then, of course, sometimes it would just attempt the full answer, maybe prematurely, which could be right or wrong. They tracked all of that.
So they have this way to mimic the back and forth. But I remember reading they didn't just do this one sharded test. They had comparisons.
That's right. They needed baselines and controls. So the main comparison was full versus sharded.
Full being the original, complete instruction given all at once.
Exactly. Single turn, all info up front. That's the benchmark.
Yeah.
Then sharded is the turn-by-turn reveal we've been talking about.
Okay, clear baseline. What else?
They had one called concat.
Huh?
Here, they took all the individual shards
Yeah.
and just pasted them together into one big prompt, sometimes as a list,
Why do that?
to see if just the act of breaking the instruction into pieces, even if delivered all at once, messed things up. Was it the breaking down or the turn-by-turn aspect?
Ah, isolating the variable. Smart.
Yeah.
Any others?
Yep. 2 more that mimic how some AI agents work. Recap was like the sharded conversation, but on the very last turn, the user restated all the shards together.
Well, like a summary at the end. Okay, just to recap, here's everything.
Exactly that. And then there was snowball. In this one, each new turn revealed a new shard and repeated all the previous shards.
So the context kept growing and being reinforced each turn.
Right. The AI always had the full history explicitly stated in the latest prompt.
Wow, that's a really thorough set of experiments. So, okay, across all these setups, 15 LLMs, 6 different task types, What was that big headline finding again?
The big one was that average 39% performance drop when moving from the full, setting everything up front, to the sharded, setting information revealed turn by turn.
39%. That's huge. And it wasn't just one model or one task.
No, it was consistent. Across the board. Big commercial models, open source ones, tasks like coding, database queries, math, summarizing text, generating text from data. Pretty diverse stuff.
And you mentioned this could happen even in really short conversations, like just 2 turns.
Exactly. That was one of the really striking things. You don't need a long, rambling conversation for this problem to appear. Even just one follow-up clarification, one extra piece of information could be enough to significantly degrade performance.
Which leads to this idea they call lost in conversation.
That's the term they use, yeah.
It definitely paints a picture. What does that actually mean? How does an LLM get lost?
Basically, if the model makes a wrong assumption or goes down a slightly wrong path early on, maybe because it only had partial information, it finds it incredibly hard to recover later. Even when it gets corrected or gets more information, it seems to get anchored to its earlier incorrect state.
Okay, so they see this big drop. They call it getting lost. Did they dig into why? What's causing this drop?
They did. They tried to decompose the performance. They looked at 2 things, aptitude and unreliability.
Aptitude and unreliability. Define those for us.
Sure. Aptitude is essentially the model's best possible performance on a task. Like, if everything goes right, how well can it do? Think of it as its peak capability.
Okay. Its potential.
Right. Unreliability, on the other hand, measures the variability. It's the gap between the model's best performance and its worst performance on the same task type. Is it consistently good? Or does it sometimes nail it and sometimes completely fail?
So high unreliability means it's unpredictable.
Exactly. Very inconsistent.
So the big question in these multi-turn conversations is the problem that the models just become less capable overall, their aptitude drops? Or is it that they become way more inconsistent, their unreliability shoots up?
And this is maybe the most crucial finding. The analysis showed the main driver of that 39% performance drop was a massive increase in unreliability.
That's massive.
On average, unreliability more than doubled, a 112% increase.
Wow.
The drop in actual aptitude was much, much smaller in comparison.
So it's not that the LLMs suddenly get dumber when we talk to them turn by turn. It's that they become incredibly flaky, sometimes brilliant, sometimes completely wrong on the same kind of problem.
That's a great way to put it. They become flaky. And there was another twist.
Oh.
In the single-turn full setting, they found a nice correlation. Better models, higher aptitude, were also generally more reliable. Yeah. Lower unreliability.
That makes intuitive sense. The best ones are also the most consistent.
Right. But that correlation completely vanished in the multi-turn sharded setting.
Really?
Yeah. In multi-turn, all the models, even the top performers, showed high unreliability. Being smarter in the single-turn sense didn't protect them from becoming inconsistent in conversation.
That is a real eye-opener. So unreliability is the big bad here. Did they figure out why they become so unreliable? What mistakes are they making when they get lost?
They identified a few patterns. A big one was premature answer attempts. The model tries to be helpful, jumps the gun, and gives an answer based on incomplete info.
Right, tries to guess too early.
Exactly. And then it struggles to incorporate the later information that contradicts its first guess. Another issue was answer bloat.
Answer bloat.
Yeah, when it tries to correct an earlier mistake, the answers can get really long and convoluted. It's like it's trying to awkwardly stitch the new info onto its previous wrong answer instead of just starting fresh.
Getting tangled in its own explanations.
Kind of. They also saw models over-adjusting to the last thing the user said. They focused too much on the most recent shard and seemed to lose context from earlier turns.
Forgetting the history.
A bit like that. And finally, just being overly verbose in general seemed correlated with getting lost. Maybe more words mean more chances to make faulty assumptions.
Interesting. Did giving them more thinking time help, like using those chain of thought or reasoning models?
They tested that with specific models capable of that. And surprisingly, no. It didn't really prevent them from getting lost in the multi-turn setting.
Huh. Why not?
The researchers theorized it might be because those reasoning models often produce more verbose outputs, explaining their steps. And as we just said, verbosity itself might be part of the problem in these scenarios.
Right, potentially introducing more points of failure. What about that gradual sharding test, breaking things into like 2 pieces versus 8 pieces?
Yeah, that was revealing. They found the lost in conversation effect kicked in significantly, even when instructions were split into just 2 shards.
So even a single follow-up clarification can trigger it.
It seems so. It's not just a problem for long, complicated dialogues. It points to a fundamental difficulty with integrating information sequentially, even in short bursts.
Okay, this definitely has implications for anyone building systems on top of these LLMs, like AI agents.
Huge implications. It suggests you can't just rely on an agent framework to magically handle multi-turn complexity if the core LLM itself is prone to this unreliability and getting lost. The foundation is shaky.
The agent can manage the dialogue flow, but if the underlying model loses the plot.
Exactly, the whole thing can still derail.
And those recap and snowball tests were designed to mimic agent strategies, right? Reminding the LLM of the context. Did those help?
They did help, yes. Recap, where everything was summarized at the end, showed a noticeable improvement. Snowball, repeating everything each turn, helped a bit too, maybe more modestly.
But did they fix the problem? Did they reach the same performance as the single turn full instruction?
No, that's the key.
Yeah.
They reduced the gap, but they didn't close it. It suggests that while these strategies are helpful band-aids, they aren't a substitute for the LLM itself having better native multi-turn reliability.
Okay. So for the LLM developers themselves, the folks building these models, what's the main takeaway?
The big message is, focus on reliability, not just aptitude. We need models that aren't just powerful in benchmarks, but are also consistent when handling information that unfolds over time. That multi-turn robustness is crucial.
And they looked at temperature settings too, didn't they? Like making the output less random. Does that fix the unreliability?
That's a really interesting point. Lowering the temperature did improve reliability in the single-turn full setting.
Yeah.
Made the answers more consistent.
As you'd expect.
Right. But it had a much weaker effect in the multi-turn sharded setting. The unreliability was still significantly high even at low temperatures.
So it's not just about random chance and word choice. It's a deeper issue with understanding and tracking the context across turns.
Seems like it. Even when the output generation is more deterministic, the underlying process of integrating the sharded information seems flawed.
Okay, so for developers, build for reliability. What about for NLP practitioners, people using these models day to day?
The big one is evaluation. Don't just rely on single-turn benchmarks if your application is conversational. You need to test in realistic multi-turn scenarios. This sharding approach might even be adaptable as a way to create better evaluation data sets.
Test how they handle incomplete info over time.
Exactly. And they did try sharding a translation task, interestingly.
Oh, yeah. How did that go?
It didn't show the same big performance drop. The LLMs handled sharded translation much better.
I have the difference.
They think it's about the task properties. Tasks prone to getting lost seem to be generative, complex with lots of specs revealed piece by piece, and non-decomposable. You can't just solve parts independently.
Like coding or math problems from the shards?
Right. Translation is often more sentence by sentence, more self-contained, less chance for those cascading errors across terms.
That makes sense. So bringing it back to us, the users interacting with chatbots or AI assistants. Based on all this, what's the practical advice?
They give 2 main suggestions. First, if time allows, try again. Meaning, if the conversation goes off the rails, if the AI seems lost, don't necessarily keep trying to correct it within that same chat. It might be faster and more effective to just start a completely new conversation.
Abandon ship and start fresh.
Pretty much. Because of that unreliability, a new instance might just work better by chance, avoiding whatever wrong path the first one went down.
Okay, that's useful. It feels counterintuitive, but maybe saves frustration. What's the second tip?
Consolidate before retrying. If a conversation isn't working, or even if you're starting a complex task, try to gather all the important details and constraints into one single comprehensive prompt.
Ah, like doing the concat setup yourself.
Exactly. Feed it everything up front if you can. It plays to the LLM's strengths in the single-turn setting and avoids the pitfalls of the multi-turn unreliability. Lots of experienced users kind of do this already, right? They refine their prompts based on failed attempts.
Yeah, definitely. Combine everything into one master prompt.
That seems to be the most reliable way currently.
So wrapping up, the big picture seems to be LLMs are amazing at processing lots of info given at once, but they really struggle with the dynamic piece-by-piece nature of human conversation, especially when things aren't perfectly specified from the start.
Absolutely. This lost in conversation issue, driven by that spike in unreliability, is a fundamental challenge. It shows we're still a ways off from AI that can truly understand and participate in conversations the way humans do.
And it really underlines this gap, doesn't it, between how we test these models in labs using single-turn benchmarks and how we actually want to use them in the real world.
Definitely. We need evaluation methods and ultimately models that are much better suited for these dynamic multi-turn interactions.
So maybe a final thought for everyone listening. Reflect on your own interactions with AI assistants. Have you had that feeling where it just completely lost the thread of the conversation?
Yeah, think about when that happened. What might have caused it, based on what we've discussed? Was the initial request maybe a bit vague? Did you add information later that it seemed to ignore?
And looking forward, what improvements do you really want to see? How can these systems become more reliable partners in conversation, not just impressive single-shot answer machines,
Yeah.
something that you want?